something totally bizarre. Um, so so on Wednesday we were still doing vectors and we were looking at our components of vectors in 3 dimensions. And one of the things that we also did is if I have a force vector, this can be my scalar vector or my scalar times a unit vector. So what we're going to play with today is writing vectors and finding certain things out with forces and getting the various components and projections, because that's what we were doing, and looking at unit vectors. So remember one of the things that we said, and this, the notes I was using on Wednesday, I was using the notation where if I have a vector, I have any vector like this, we get you guys get to learn how to write in 3 dimensions pretty well. So I get my projections on my various places. So there's my 3 dimensions. And we do from my X to my vector. This could either be theta X or it can be alpha. Those are our usual notations. If I'm going from B to my vector, this is either going to be theta Y or beta. This is X, this is Y, and this is Z. And if I'm going from my Z vector, this is either theta Z or gamma. And it just is what convention somebody is using. It's not, there's nothing really special about it. Now I was going to look at it and I just didn't get to it. I was going to look at being able to do what they have in the FE manual, and I don't remember what they have in the FE manual. But also remember that 1 is equal to the cosine squared of alpha plus the cosine squared of beta plus the cosine squared of gamma. So I've got those pieces all the way around. So if I were doing this vector, and we're going to go ahead and I'm going to make up numbers, which is a bad thing on a Friday, right? It's a totally bad thing on a Friday. But I'm going to say that this is 7. This is going to be 3. And this is going to be 5. So if I'm doing my 7, and we're going to go ahead and call these feet. And so if I'm looking at R, this is going to be my R vector. I can write my R vector as 7 in the I direction. Nope. See, I told you it's a bad thing on Friday. It's 3 in the I direction plus 7 in the J direction plus 5 in the K direction. Okay. And then if I am doing, so if we look at the magnitude of R, right? Magnitude of R is going to be the square root of 3 squared plus 7 squared plus 5 squared. And I'm making up numbers and this is going to be a challenge, right? 3 squared plus 7 squared plus 5 squared. It's going to be the square root of 83, which is going to give me 9.1 feet, because that's what we're in. Now, if I want to find, make sure I'm not screwing up, but I probably am. Okay. I want to find the cosine of alpha or the cosine of theta x, this is just going to be Rx divided by my magnitude. So if I want to find that value, this is going to be 3 divided by 9.1. So my alpha or my theta x, take 3 divided by 9.1, do the inverse cosine. That one would be 70.8 degrees. Cosine of beta or my cosine of theta y is 7 divided by 9.1. And remember, depending on your problem, we're going to go ahead and carry it all the way. But remember your problem, you may just need to leave it in the ratio. You may not necessarily have to go ahead and calculate the angle. I just need to know what the cosine of cosine of that angle is, and I can leave it in my ratio. I don't necessarily have to define what my angle is unless I'm being asked for it. So we go there. So this one is 39.7 degrees. And for gins and giggles, we'll go ahead and get the gamma. And that one is 5 divided by 9.1. So my gamma and my theta z. $56.7 degrees. That's a different way of looking at our lovely vectors. So let's take a vector. And basically what we're going to do is I have a bolt here. So we've got a bolt. And we're going to apply a force vector in this direction. And we're told that our force vector is 80 newtons. So our force vector is an 80 Newton vector. We're given our alpha as 60 degrees. And we're given our gamma as 45 degrees. We want to find Fx, Fy, and Fz, which means we're going to use our force cosine of our alpha, F cosine of our beta, and F cosine of our gamma. Well, we can do alpha and gamma pretty quickly. So that's 80 cosine of 60 degrees. And this is 80 cosine of 45 degrees. That one is 40, and that's 40 newtons. This is going to be 56.6 newtons. Now, beta, cosine of beta is going to equal the square root of 1 minus cosine squared alpha minus cosine squared gamma. So I've got 1 minus And this is going to be 0.25. This is 0.5. So it's going to be the square root of 0.25. That's going to equal 0.5. And given our picture, okay, because that's the thing that we got to do, I've got beta is equal to cosine of 0.5. Oh, sorry, cosine. Try that again. This says it's going to be 60 degrees, but because of where I am, remember, I've got to deal with my other part. Beta is going to end up being 120 degrees. Unless I did something. Oh, I did that right. Did that right. That's 0.25. That should be 0.5. That's minus 0.75. That's that. That's 0.25. But I end up giving my pictures. But anyway, that's going to give me that this one is equal to 40 newtons. But I've got to look at my picture to know that it's 120 degrees. This will give me the right answer here, but if I'm trying to find my angle, you've got to look at your picture. Yeah. Yep, that was 40 newtons because it's the same value. Yeah, oops. Yeah. Yeah, because what we actually figure out here is the reverse one. So it's this is one that you're going to have to look at the picture. Okay. So you've got like a lot of the problems in the 60s in our book, because this problem actually was 261. That was actually the problem in the text. It's 261. It's just playing with our vector components to get there. I want to do another unit vector. Well, let's do a position vector. So I've got a piece of I-bar. So that gives you an idea that it's an actual physical piece. Okay. And yes, when I went to school, we all have to do our certain things, right? And they say in order to have a well-rounded education, I had to take so many credit hours of shop or home ec. I wasn't necessarily the home ec people. If cooking, that's okay. Sewing a straight line for me is not something I can do. That is not me. So instead, I had to take a shop class. Well, the shop class that I continued to take all the way from middle school through college was drawing. Yes, I can actually draw blueprints. Mechanical drawing. Now we all do it via CAD, but I had to do it before there was such a thing as CAD. So there we are. So I've got an I bar, and this is my X, this is my Y, this is my Z. We've set it up so that my Z axis divides my I bar. And I've got a point B here. So we've got our point B, and it is going to be, this is our Z value. We don't know Z. Okay, we don't know Z. And our point A is there. So I'm going to draw my position vector. This is my point A. So we've got a cable that is going along that line. So I have this. We are told that X is 4 meters, and we're told that Y is 2 meters. So we're given our cable, and we want to determine the coordinate Z such that our cable is 8 meters long. So we've got our cable, we're told what our cable is, but we want to know what the coordinate Z is so that it's at its highest point. So if I'm drawing my position vector, R, our X is 4 meters in the I direction. Our Y is 2 meters in the J direction, but we don't know Z, and that's in the K direction. But we do know the magnitude of R is equal to 8. So I'm going to get 8 is equal to the square root of 4 squared plus 2 squared plus Z squared. So 64 is equal to 4 squared plus 2 squared plus Z squared. So I get 64 minus 16 minus 4 is equal to Z squared. If I've done my arithmetic right, but it's Friday, so you guys have to keep me honest. That's 44. I get that this is 6.63 meters. And this is, just for grins and giggles, this is question 290. All right. Time. We're going to do a unit vector. Let's see. Do I want to do that unit vector, or do I want to do a more fun unit vector? We're going to do more fun unit vector. See how far we can get. So I have a post. And my post is positioned such that this distance between the Z-axis and my post is 0.75 meters. Okay, there's my post. I have a cable that's tied to this spot here. So that was not a good spot. It's tied to this spot here. And we're told that this distance is 1 meter. And this distance is 2 meters. I've got another one. Okay, so this is point A, this is point B. And we're told for this one, so you all get to learn how to draw in all kinds of fun dimensions. We're told that this one is 40 degrees and this side is 2 meters. And then we're told that this is 3 meters. We're given a force along this direction. F is equal to 400. Oops, we're going to label this differently. I'm going to keep consistent labeling. So there's A to C. So force AC is 400 newtons. And force AB is going to be 250 newtons. All right. So how I would approach this problem is I'm going to figure out this side and I'm going to figure out that side. So I'm not having to carry sines and cosines through everything, right? So if this side is going to be 2 sine 40 degrees, this side is going to be 2 cosine 40 degrees. So I'm going to end up with 1.532, and I'm going to keep those just because it's not too bad of a number to deal with, but I'm not carrying this all the way through my problem. I'm going to figure out this one. And this one is 1.286. So we have our units. So we want to find our unit vector A, B. And remember that this is going to be RAB divided by the magnitude of RAB. So I'm going to find RAB first. So I'm going to do AB first, right? So my R in the I direction, which is this one, I'm positive 1.532. In the J direction, I'm 1.286 minus a minus 0.75. That's using our vernacular, the R minus, or, RA minus R, all that good stuff. Or you can look at it and go, okay, I'm going 0.75 there, and I'm adding that to it. I don't care how you get there. And then my Z, I'm in the downward direction, so I'm going to be a minus 3 in the K. So now I'm going to be 1.532 plus I'm going to be 2.036 minus 3K. So now I got to find the magnitude of RAB. I get the square root of 15.49. That's going to be 3.94. So now my unit vector AB is equal to 1.532 divided by 3.9. 1.532 divided by 3. I did it again. 3.94. I get 0.389. I get 0.517. I get minus 0.76. Okay. And I can check and verify that that is equal to 1. So we're going to verify it. So we want to double check. This is a check, right? Because I'm going to get my square root here. And I've got 0.998. So that's off for rounding. But that's a way to check it. The other check is if you know you got something that's over 1, you're in trouble. Yeah, you got something over 1, you're in trouble. So we've got our unit vector. So our force AB vector now is just going to be our magnitude, which was 250, times our UAB, which is 0.389. Gives me 97.25 in the I. $129.25 in the J. And 190 in the K. And now you can do it for the other one. And I'll give you what the answer is and let you guys do it. FAC is going to equal 221 in the I minus 27.7 in the J, and 332 in the K. Then you're going to do a resultant, which is FAB plus FAC. And that's going to have a magnitude of 620 newtons. And then you can calculate the alpha, betas, and gammas. And what we're going to find in statics is that I am now at the point that I don't have time enough to do another problem. And you guys will have a test over chapters 1 and 2 a week from today. Questions? Anybody got questions? Anybody got issues? This one. Huh? Yeah, well, you know, I don't know, it could be issues. I'm the advisor for most of you, so you might have issues. All righty, and I will call security again on Monday so that hopefully we won't have this problem again.